Hi, this is Dave Johnson with another edition of Math Off Topics. Today I'm going to talk about asymptotic limits in rational functions. I'm assuming because you're taking calculus or have had calculus that you know what a rational function is. But basically, a rational function is a ratio of two polynomials. And so when I talk about asymptotic limits, in this video, I'm going to limit the discussion to horizontal asymptotes or vertical asymptotes. I plan to do another video in which we'll talk about something called slant asymptotes. They're also known as oblique asymptotes. But let's get into it. So I want to just start with a really simple rational function and make sure that we're on board with that. So 1 over x, which is rational, and it also has both a vertical asymptote and a horizontal asymptote. We can tell what the vertical asymptote is going to be, and also the horizontal asymptote. But let's do the horizontal asymptote first. So by looking at what the behavior of the function is as x gets very, very large, so as limit as x goes to infinity, that's what we mean by a horizontal asymptote. So what does the function do as x gets larger and larger and larger? Well, if it's approaching a constant value, if it's approaching a horizontal line, that horizontal line is known as the horizontal asymptote. And in this case, as x gets larger and larger, 1 over x gets smaller and smaller, and the limit as x goes to infinity, 1 over x is going to go to 0. And so we know the limit. It's 1 over infinity is 0. And we can plot this on a graph, and now it's useful to have a starting point. So if x is 1, y is 1, 1 over 1 is 1. And as x gets smaller, or as x gets larger and larger and larger, the 1 over x gets smaller and smaller and smaller. And so it's approaching, in this case, the x-axis. The x-axis is the horizontal asymptote. And also on the other side, if we were going to look at as x goes to negative infinity, I haven't written that here, but if x goes to negative infinity, x is getting more and more negative, but it's getting a bigger negative value, and 1 over a very large negative value is going to be a small negative value. And so we can see that that's going to also approach the x-axis, but in the other direction. Okay, now the key idea let me just write this down. So the horizontal asymptote is y equals 0. Okay, so the vertical asymptote, that gives some students difficulty sometimes. If x is approaching 0, now you remember, if x is equal to 0, then 1 over 0 is undefined, and the function cannot exist at that point. But if x is approaching 0, and let's suppose that it's approaching from the right. So, and notice I've written x approaches 0 plus, so that means approaching 0 from the right. So x is getting smaller and smaller. Well, a ratio where the denominator is getting smaller and the numerator is a constant, then the 1 over that smaller value is bigger. And so the 1 over x is going to get bigger and bigger and bigger as x gets smaller and smaller and smaller, as long as x is positive. And so we know the answer. We know that it's either going to be plus or minus infinity. And in this case, it's going to be positive infinity because the numerator is positive. So a positive divided by a positive is positive, and 1 over something that's going to 0 is going to go to positive infinity. And we can see that on the graph. As x gets smaller and smaller, approaching 0, the y value is going to get larger and larger. And so it's going to approach the y-axis asymptotically, and y is going to go to positive infinity. Now, what happens if you're approaching from the other side? So here we're approaching 0 from the left side, and we know it has to be infinity. or positive infinity or negative infinity. We know that the vertical asymptote, the function, the rational function, is going to go to either positive infinity or negative infinity. So, so let me just go ahead and write an infinity symbol here, but it actually is going to go to negative infinity because x is negative. And in positive, so 1 is positive, x in this case has got to be negative because it's going to 0, but it's approaching from the left, so it's approaching through negative values of x. So a positive divided by negative is negative, but the result is going to be some sort of infinity, either positive infinity or negative infinity. It has to be negative infinity. So those are the three, well, really two asymptotic limits. Now notice, and let me go ahead and graph this. So as x gets smaller and smaller in absolute value, but it's getting more and more negative, or closer to 0, the y value is going to go to negative infinity. And so that's actually what the graph looks like. You could graph this on Desmos or on your graphing calculator. And so the vertical asymptote here is your y-axis. And so let me write the vertical asymptote is x equals 0, because x equals 0 is the equation of a vertical line, and in this case, the y-axis. Okay, well, let's take a more complicated example. Oh, and I do want to mention, so for horizontal asymptotes, you may have learned that there are some rules that allow you to determine what the horizontal asymptote is. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is going to be y equals 0. So we've seen that's actually consistent with that rule that you learned. If the numerator degree is equal to the denominator degree, which it's not in this case, then it does something different. I'm going to show you that in the next example. Okay, so let's look at the function f of x equals x plus 2 divided by x plus 1, and we want to look at the asymptotic limits. And so again, as x approaches infinity, now the thinking here is a little different. So first of all, let's convince ourselves that you're going to get an infinity over infinity indeterminate form. Okay, so if x goes to infinity, x plus 2 is going to be infinity, x plus 1 is infinity, so you get infinity over infinity. So you need to think about this a little bit more. And this is where the rule that you may have learned before comes into play, and I'm going to show you a different way to think about it as well. So the rule that you may have learned was if the numerator degree is equal to the denominator degree, then you take the ratio of the leading coefficients, and the leading coefficient here is 1 in the numerator. The leading coefficient in the denominator is 1. 1 divided by 1 is 1. And so the limit is going to be 1 because the horizontal asymptote is y equals 1. Now, that may not be very satisfying, and indeed, I wouldn't be happy with that. So let's just kind of put this up here, and let me erase this 1 and show you a different way to get the answer. So, and this, your calculus teacher may actually be showing you this way. So I'm going to multiply top and bottom by 1 over x. Now you might say, well, why 1 over x? Well, I'll show you in a minute. So if we, and 1 over x divided by 1 over x is just 1, as long as x is not 0. And of course, as x goes to infinity, there's no way that x could ever be 0. And so if we multiply, so distribute in each case, okay? So if we multiply this out, so limit as x approaches infinity, Now the 1 over x times x is going to be 1. The 1 over x times 2 is going to be 2 over x, so plus 2 over x. That's in the numerator. In the denominator, 1 over x times x is 1, again. And the 1 over x times 1 is, so plus 1 over x. So all we did was multiply top and bottom by 1 over x and distribute it. But we're carrying the limit with us, as we always do. But notice what happens when we take the limit. The limit of 1 is 1, but the limit of 2 over x is 0. Just like up here, limit of 1 over x as x goes to infinity was 0. If you multiply that by 2, you still get 0. So 2 over x goes to 0. 1 over x goes to 0. And so you get 1 over 1, which is equal to 1. So again, we get the same answer. The limit is 1, and that's consistent with the horizontal asymptote. Okay. So, and let's just go ahead and draw this horizontal asymptote here on the graph. I'm not going to plot anything yet, but we do know that that's the horizontal asymptote. Okay, now let's look at our vertical asymptote. Why do we think that as x goes to -1, that would give us a vertical asymptote? Well, anything that's going to make the denominator 0 in a rational function, assuming that the factors don't cancel, is going to give us a vertical asymptote. So if x plus 1 is set equal to 0, then x is equal to -1. So here's a -1, and let's approach it from the right. Now, if you're approaching, -1 from the right, then your numerator, you're approaching -1, so this is going to end up being positive. Let me just put a little plus sign up there to remind us that it's positive. But if you're approaching -1 in the denominator from the left, or and from the right in this case, so what happens? X plus 1, if you're approaching -1 from the right, you're getting closer and closer to 0, but from values of 0 that are greater than 0. So x plus 1 is going to be greater than 0 as long as you're approaching -1 from the right. And so we're going to get a plus down here. And so what's going to happen is you're approaching infinity because the x plus 1 is getting closer and closer to 0. But because it's positive divided by positive, you're going to get a positive infinity. So we have a vertical asymptote at -1. And we're going to be approaching the vertical asymptote. It's going to go to positive infinity. Now, we haven't drawn the rest of the graph, and there's other things we can do to help us, but this is a good way to think about it to tell you whether you're approaching positive infinity or negative infinity. Okay, well, let's do the next one. Let's approach -1 from the left. Now, that doesn't change the numerator, because if you're approaching -1 from the left, the x plus 2 is still going to be positive. Let me put a little plus sign up here. But now, if you're approaching -1 from the left, x plus 1 is going to be approaching 0, but from smaller values of 0. And so that is going to end up being negative. And so your denominator is going to be negative because you're approaching -1 from the left. And so positive divided by negative is negative, but you know that the result has to be either a positive infinity or a negative infinity, but we've shown that it's negative, so this result is negative infinity. And so I can draw that part of the graph. We know we're going toward negative infinity. Now, there's a couple of other things we can do, but if we don't do anything else, we know what has to happen in this graph. We know that this has to approach the horizontal asymptote asymptotically. And we know that on the left side that it's going to go through the x-axis and approach the horizontal asymptote asymptotically from the other side. Now, granted, my graph is not all that pretty, but that's exactly what happens. And in a moment, I'm going to show you the Desmos graph for these. So let me now label the vertical asymptote. So we know the vertical asymptote here is x equals -1. And I can draw this arrow here, so x equals -1, which is the equation of that vertical dotted line, our vertical asymptote. And this was y equals 1, which is our horizontal asymptote. Now, let me just very quickly show you the Desmos graph corresponding to these. So the 1 over x, you can see that as x gets larger, 1 over x gets smaller and approaches the horizontal asymptote. As x gets smaller but positive, the 1 over x is going to get larger and larger and approaches the vertical asymptote. Likewise, on the other side, as x gets smaller and smaller but negative, the 1 over x goes to negative infinity. And as x gets more and more negative, so larger in absolute value, the y value gets closer and closer to 0. Let's look at the other example that I did. So the x plus 2 divided by x plus 1. So so remember our vertical asymptote was -1. And so if x is greater than -1, then x plus 2 over x plus 1 is going to go to positive infinity as x gets closer and closer to -1. But as x gets bigger and bigger and bigger, you're going to approach the horizontal asymptote, which we showed was y equals 1. And likewise, if you're on the other side of the vertical asymptote, as x gets more and more negative, bigger and bigger negative values, the y value, the x plus 2 over x plus 1, gets closer and closer to the horizontal asymptote, which we showed was y equals 1. And likewise, as x gets closer and closer to -1, then, but still on the left side, so it still gives you a negative denominator, then the y value is going to go to negative infinity. So I hope this video has been helpful, and if you liked it, please subscribe and like, and I will see you next time.